so we're going to go ahead and solve another absolute value equation. This time, this one's going to be a little bit different than the other two because it's a special case solution. So it's either going to be a no solution or an all real numbers, and we'll talk about the difference as we go through the process. Okay? We're still going to solve algebraically and graphically. Graphically first by using our smartboard here. So the left side of our equation, so 3 absolute value of 2x plus 4 minus 6, that's all going to go into y1. It's going to look like a V when you graph it, and that's your absolute value section. The negative 12 is going to go into y2. It's going to look constant, like a linear piece. And we're going to look for where these two sections intersect. So when I go to my calculator, I want to go back to y equals. I want to clear out what's in there from an old problem, and I want to put in our new problem. So when I type in our new problem, I want my coefficient to go first, so I want my 3, then my absolute value, so math, number, ABS, 2x plus 4, come outside my absolute value and type in my minus 6, that's my absolute value section. In my y2, I want a linear section, so negative 12. I'm going to have to mess with my window a little bit to show this graph. Negative 12 is outside a standard window of 10, so I want to go to my window. And I want to change my y-min to be, let's just do a negative 15 just to make sure it shows up. I want to count my y's by 2 just to make my picture a little bit nicer. Then hit graph. So there's my absolute value piece I want to see. And down here's my linear piece I want to see. And when you first graph this, a lot of kids and a lot of students think that they've messed up because the absolute value and the linear piece are not intersecting. But that's the actual point I want you to notice today, is in the past two examples, your two graphs have intersected, therefore you've had two solutions. But if these two pieces do not intersect, there cannot be a solution. Therefore, the easy answer to this graph, to this equation, is simply a no solution. If they do not intersect, they can't have an answer. So that's the graphical way. Let's confirm this using algebra. So I'm going to go back to my screen here. Same equation. Let's solve this algebraically. Now the steps are the same. You still want to isolate first. So we're going to add our 6 first. Divide by 3. Divide by that coefficient to get your absolute value equal to a negative 2. And again, this is the crucial step. You have to have an isolated absolute value, and the reason why is absolute value represents distance. And right now we have absolute value set equal to a negative number. And so the one thing you have to make sure that you understand is distance, whether you go forward or backwards, distance cannot be negative. Therefore, this is algebraically proving the same answer you got graphically. Distance cannot be negative, therefore there is no possible answer to this equation. It's no solution problem.